weighted graphs, and minimum spanning trees. A weighted graph is one where extra information has been added to the graph, and this information can be distances or time or cost. So for example, here we have 5 towns, and there are the kilometers listed as the distances between the towns and the main roads that connect these towns. The question is, what is the shortest path from M to H? So what you can do is you can list every single possible path from M to H and then add up the distances. So if you go from M to B to H, it's 293 kilometers. M to G to H is 307 kilometers. And if you go M to G to W to H, it's 363 kilometers. So clearly, MBH is the shortest distance. You don't always have to detail every path. I mean, you could have clearly seen that MGWH was going to be a very long way, and so we didn't need to do it. Often you can just pick one or two likely candidates. Minimum spanning trees combine spanning trees and weighted graphs, and you create a minimum spanning tree. This is often used as a method of reducing costs. So the example we have is this university has 9 buildings with connected footpaths. If covering, so roofs, were ordered so that students can get between buildings without the risk of getting wet from rain and etc., what is the minimum amount needed? So if you look at this, there's a lot of information there. How do I start? Fortunately, there is a method. And that method is called Prim's algorithm. And this is what Prim's algorithm is. Step 1, choose any vertex within the network. Doesn't make a difference which one, because you have to connect to all the vertices anyway. Choose any vertex within the network. Step 2, find the edge with the lowest value connecting this vertex to another vertex. So, for example, let's pick E. Why not? Here's E. I'm going to make that bigger. E to F is 445. E to A is 225. That's the shortest path. So that's the one I'm going to do. Step 3. Look at all the edges connecting these 2 vertices and choose the lowest one. So this is still 145. That's 130. So I'm going to pick that one. Step 5. Rinse and repeat. So you keep looking at all the edges that are connected to these vertices and always pick the lowest one. However, it's a tree, so we can't have any loops or circuits. So just keep that in mind. So 130, 130, 135, 50, 125, 120. Now all my vertices are connected, and that is the shortest path. And then once you've done your minimum spanning tree, you can then redraw it as a subgraph so you can clearly see what is going on. And the answer is the total distance is 145 meters.